Hi everyone, my name is Zheng. I'm presenting our CVPR work, Volumetric Object Selection. This is a joint work with Asim, Brian, Alex, and Oliver. In this work, we are interested in the task of 3D object selection. Towards this goal, we introduce an approach to select objects in 3D neural volumes based on 2D user input. Our method works on the state-of-the-art neural volumetric 3D representations, such as multiplane images (MPIs) and neural radiance field (NeRFs). It uses the 2D scribbles as the user input. As shown in the two examples, the output selected objects is accurate and can be rendered to novel views. Specifically, our method, which we refer to as NVOS, takes as input multi-view images of the observed scene, the learned neural volumetric representation, and a set of 2D scribbles in one view. It then estimates a 3D segmentation of the desired objects, which can be rendered into novel views. To conduct 3D object selection with only sparse and noisy 2D user input, we construct an expressive voxel representation, VP, for each voxel in a neural volume. The voxel representation VP contains three components. First, a discretized neural feature extracted from the learned volume. Second, a 3D positional encoding of the voxel. Lastly, we introduce a novel multi-view image feature embedding, which is inspired by MVSNet. We find this information to be particularly useful as it overcomes the limitations of the discretized neural features. Please check our paper for more technical details. After the voxel feature computation, we train an MLP-based classifier network for foreground and background classification, given the user-provided scribbles. For training, we lift the 2D foreground and background scribbles to 3D using the known camera pose, and then train the network using a standard binary cross-entropy loss. Since our network is trained with limited supervision, the final prediction on the entire volume is occasionally noisy. We hence introduce a post-processing step based on a 3D graph cut. These steps helps to address the issues of floaters and incompleteness in the final output. For evaluation, we annotate the LLFF and shiny datasets with ground truth masks and human scribbles. The labels are of very high quality, which we obtained using a professional service, and are available for public use on the project website. For experiments, we first render the foreground voxel locations to a novel view for 2D mask evaluation. On both LLFF and shiny datasets, our method outperforms all the 2D and 3D baselines for both mask error and IOU score. Besides, our model segments the foreground objects in 3D and thus is able to render the objects in novel views. Compared to 3D graph cut, ours achieves more realistic rendering result with higher SSM, PSNR, and lower LPIPS score. Here we present qualitative results. In the left column, we show the input scene and the user scribbles. We then show the foreground objects and masks predicted by baseline method. Our method demonstrates more accurate results with less noise and better visual quality. Please check out the paper and more results on the project webpage. For more information, visit the poster session 2.1 at 10 a.m. to 12:30 p.m. on June 22. Thanks for watching.